So we want to find the expected amount of time it takes to get back to state 1 given that we're initially in state 1. Or you could think of it as the infimum of the time, or the number of steps. So mu1 is equal to, so you have a 2/3 chance you initially get back right away. So 2/3 chance you have one step. But then you have a 1/3 chance that you take one step, but that takes you to state 2. So then you have to add in the expected amount of time it takes to get from that state. So to get to state 1 again, given that you're now initially in state 2. Problem with that is we don't know this value. So you can go to the second row of the matrix and think about the expected value that it takes to get to state 1, given that you're now starting from state 2. So there's a 3/4 chance you only have to take one step. So 3/4 chance you have 1, but there's a 1/4 chance you take one step, but that leaves you in state 2. So you expect an amount of time again to get to state 1, given that you're now initially starting in state 2. So you can solve for this value. That gives me 3/4 the expected value of t1, given that you're in state 2, initially in state 2, is equal to 1. That gives me the expected amount of time it takes to get to state 1, given that you're starting in state 2, is equal to 4/3. Take this value, plug it back into the initial equation. So that gives me mu1 is equal to 2/3 plus 1/3 plus 4/9. So mu1 is equal to 1 plus 4/9. So mu1 is equal to 13/9.